everyone, welcome to Snark Chocolate, where we unwrap the bittersweet layers of building zero-knowledge projects. I'm Omer, and I'll be co-hosting this episode with Queenie. Today, we're thrilled to be joined by Brett Carter, VP Product at Risc Zero, and Jeremy Bruestle, co-founder and CEO at Risc Zero. We brought them to discover what fuels the hype for Boundless and unpack everything else this trailblazing team is cooking for us. So to kick things off, could you please introduce yourselves and Risc Zero?
So I'm Jeremy, the CEO and co-founder of Risc Zero. And at Risc Zero, we're really trying to sort of bring ZK to every developer and every chain, both through our ZKVM and through our new initiative, Boundless, which we'll be talking about a bit. So,
That's great. I'm Brett Carter, lead the product team here at Risc Zero. Was previously a part of the team over at R0 Labs working on Mina protocol. Got ZK build around 2021, working on that project, and yeah, been around the blockchain space since late 2014 actually. So yeah, good to be here. Thanks for having us.
Awesome to have you guys. So Risc Zero, the company, has been running for a while now. Notably, you have quite a few the first to do X under your belt. Can you walk us through the history of the company, highlighting interesting stories and important milestones?
yeah, absolutely. So, I my background is I really like math a lot, and I end up starting companies based on where I discovered people are building new math that has impact on the world. And I've been actually following ZK for probably 7 or 8 years, and was really interested in it, but it just didn't seem practical because the computational issues involved. And then around the time of Ellie's Stark paper, it became clear to me that it was starting to become practical, and I started to try to convince all my friends, hey, let's go build a ZK company. But nobody liked the idea that to program ZK, you make some kind of crazy polynomial constraints over finite field elements. All my programmer friends said that's totally unusable. And then at some point, me and the other co-founders, Frank and Brian, were sitting around, and we basically came up with the idea of building a VM that could run normal Risc-V code, which would allow you to put normal programs into ZK. So now you could program in Rust or C++ or ordinary languages and have that run in ZK. And that seemed like a huge unlock. So we founded the company. We originally knew that the blockchain use cases were critical, and that ZK could have a huge effect on blockchain scaling. So we started building out the ZKVM, and we were the first people to have a working Risc-V ZKVM. We had a 1.0 version of that earlier this year in the summer. But in part of that process, we also built out the first version of continuations to allow sort of arbitrarily long-running programs to be used. We were the first people to have Rust running inside of a ZKVM. And then I think we started looking at the idea of making a ZK EVM by just running a normal EVM inside of the ZKVM, which we called Zeth. I think that's about when Brett Carter came on board as well, right?
Yeah, so I joined the company right around that time. So back in May of last year, I was previously the PM for the cryptography and the protocol teams at R0 Labs, working on Mina protocol and the underlying proof systems. And I really felt the difficulty of working with ZK systems there. There were only a couple of our engineers that could maintain the circuits that Mina was dependent on. Our development velocity was just super slow because every time we changed something, we had to rewrite the circuits or touch the circuits. And so I met a couple of the co-founders, I think it was Jeremy in Amsterdam. I actually don't remember. I don't think we figured that out, but met him at Amsterdam when DevConnect was there in 2022. And I didn't quite understand what they were building at the time, but after just kind of like keeping track of the project for a couple weeks, spending some time thinking about it, I realized what a huge unlock this would be for the development velocity of ZK, that really good backend developers could write compiled programs and get the characteristics of ZK out of programs without writing arithmetic circuits. And so I just got really excited about the project and basically said I'm going to keep an eye on the job openings and try to work there as quickly as I can. So joined the team in May, we were proving one Ethereum transaction when I joined, and that blew my mind because my concern in joining the company was about proof system performance. Like, they're quite slow. Could you really do this general purpose thing? And so we were proving one Ethereum transaction. I remember our developer Parker showed me it, and I was like, I can't believe this actually works. And then fast forward just 3 months later, we released Zeth to the world, which was the first Type 1 ZKEVM, I think ever. And we built that with 2 engineers. In I think 3 weeks, we had a working prototype. And so you imagine the hundreds of millions of dollars that had been invested into purpose-built ZKEVMs. And here, this company that took this general purpose approach was just able to pull in a couple crates and get a true Type 1 ZKEVM working in just a few weeks. And I think from the trajectory from there was really about taking the ZKVM and using it in different applications like that. So, when we did Zeth for the first time in August of last year, we ran an analysis of what it would cost to prove all of Ethereum mainnet. And I think the numbers came back. We thought it was like $170 million a year to prove Ethereum mainnet. So we were kind of like, oh crap, we have to fix this, So we got it working. But then for the last year, we've really been very focused primarily on performance and really getting that number down, getting the ZKVM to go burr, if you will. And so we're really proud to say that now you can prove all of Ethereum mainnet for well under $1 million. I think our last analysis was like about $40,000 a month to prove Ethereum mainnet. So you can see that trajectory of 170 million down to like, I don't know, what are we at? Close to 500,000-600,000 is really, really steep. And we've still got quite a few performance wins in our back pocket. So yeah, that's kind of been the rough history from my personal perspective. Along the way, we've done some really cool things like Steel. And, I guess the last thing I'll mention too is we realized in working with these teams that were interested in adopting the ZKVM, 2 primary things. Number one, that the ZKVM, while it was a big win in terms of, development velocity, there were still a lot of other challenges integrating the ZKVM into protocols, getting to production and getting on chain. And so, we realized that there really needs to be sort of an end-to-end stack for ZK. Like, there needs to be better integration tooling, a platform to deploy this to, et cetera. And then we also, we realized that the ZKVM itself, wasn't sufficient. We need to build, like, for example, Steel, so that it would be really easy to do co-processing in an EVM context and things like that. So, yeah, I think that's kind of been the theme of the stuff we've been working on the last year.
Thank you. This is fascinating, and thanks for sharing. There are few names that you dropped here while talking about the road to get to where we are today. I guess that you can also try and look at the different solutions that Risc Zero is offering today. So to repeat a few of the names and or some others. So you've mentioned Zeth and there's Steel. We've also noticed Blockstream Zero, Bonsai. There's obviously Boundless. I even saw this talk from ZK Summit about some tooling, like a compiler. Can you maybe explain how they are all connected, and what is your current focus?
Yeah, so I think by and large, the ZKVM was a massive unlock for developers to build ZK. But it's not really the whole solution, right? So getting the EVM to run inside the ZKVM, as to Brett's point, was surprisingly easy, but it still requires some amount of work, and it's something that we don't want every developer to have to redo. Similarly, Steel, for example, makes it possible to run contracts on Ethereum in ZK, including looking at the Ethereum state, which is another sort of common use case, right? And both Bonsai and Boundless help solve the problem of who runs proving. Bonsai is sort of our cloud SaaS proving solution, and Boundless is sort of our way to get proofs run in a decentralized way and be so that ZK can be used on any chain as part of sort of normal blockchain workflows, right? So I think that if you think of it as like a core product being the ZKVM, to be able to use that for all the different use cases, there's a whole variety of additional things that are necessary. I mean, we're sort of looking at Boundless as really trying to sort of solve the whole stack, from the actual ZKVM itself to getting proofs run on a marketplace, to doing aggregation, to getting proofs posted on chain, to having them verified. right? And so if you really think about it, our goal is to make it the end experience for running ZKVM as simple as possible, so the end user doesn't really need to understand ZKVMs. They don't really need to understand the decentralized marketplace. They really just need to say, hey, I want some computing done somewhere off chain, and I want to make sure it's done right. There you go, right? So I think that, to that extent, these are all sort of additive parts that work together to build this end-to-end experience we're looking for.
Yeah, no, I was just going to add, I think Jeremy nailed it. From a high level, I think you can just see the common thread between these is ZK, right? We really believe in verifiable compute, and along with ZK comes some really attractive properties, scaling, better interoperability, better security, privacy. And so, we're really just doing our best to ensure that the ZKVM can be used to help enable those value propositions.
So Risc Zero is one of the most popular libraries used by devs today. We've seen it time and time again in hackathons, where it is one of the most popular libraries, and we also know that it's an open source library which gets quite a lot of traction. So I assume that you see on your day-to-day quite a lot of usage. I was wondering if you can share some interesting use cases and stuff you see people build on Risc Zero today.
Yeah, we're really happy to see how interested really all of the blockchain space has been in adopting the ZKVM in various different ways. And so I think, at hackathons, I want to say on average, 30 to 50% of the projects use the ZKVM for all submissions at some of these hackathons. And one of my favorite examples that comes to mind was from ETH Waterloo in 2023. A team built a wallet called Bonfire Wallet, and it used the WebAuthn API. So you could you can sign with your thumbprint on your MacBook, for example, using the WebAuthn API to develop a burner wallet. So you could develop this one-time use wallet that was actually powered by your thumbprint or your biometrics. And I think there's an interesting characteristic to that is often overlooked when it comes to ZK, which is ZK provides us this really powerful capability that I would describe as cryptography Lego blocks, right? You can take these cryptographic protocols that are typically not interoperable, and you can stitch them together. And so we can take we can take WebAuthn attestation, and we can wrap that in a ZKP, make it verifiable on chain, etc. So that's a really interesting primitive. One of the ones that I think is starting to show up more, and there'll be some really exciting announcements in the next few months or so, is you can also do the same thing with JWTs. JSON Web Tokens are used for authorization in Web 2 applications. And if you verify those in a zero-knowledge proof, you can provide attestations about your Web 2 identity, the characteristics of your Web 2 reputation on chain. And so you can use that for interesting things like wallet recovery, delegation, etc. Last one I'll mention, as we look at our adoption pipeline, I want to say we're close to 100 teams that are using the ZKVM either experimentally or building a product with it. And one of the most exciting ones is actually just the use of Steel within DeFi or on-chain. So there's a team, I won't name them yet, but we will be announcing soon, that's using the ZKVM to do some really powerful things on-chain in DeFi. And so they have this problem. There's hundreds of thousands of potential addresses that they need to be able to read the state of on-chain. One S-load, which is the opcode for reading memory in a smart contract, costs about 3,000 gas. So if you need to read the state of 400,000 addresses, you can imagine that that's 1.2 billion gas, which doesn't fit into any block. Even if you wanted to split it across blocks, would potentially cost you millions of dollars as gas fees increase. And we can, in the ZKVM using Steel, with the full guarantees of validity proofs, meaning there's no optimistic scheme here. So the way that Steel enables this is you're actually able to commit to a valid block on Ethereum. And we're able to read from an RPC the state of given chains at that block, given smart contracts at that block. And so we can do these 400,000 queries directly off chain, but committed to a valid block. And when we take that zero knowledge proof that reads across the state of these 400,000 blocks, and we verify it on chain, we perform a check, we call it a Steel commitment, to ensure that that block we've committed to is in fact valid. And so you get full validity guarantees in these proofs. And that proof, doing this execution on chain, like I said, who knows, would cost, take 30 full blocks, or I think it's 40 full blocks of Ethereum execution. Whereas in ZK, we can actually generate that proof for less than $10. And so the asymmetry there in terms of cost, you can see how powerful it is, will enable completely new applications that never would have been possible on chain.
Yeah, I guess I'd like to add a little bit of something here. So I would say in terms of people using our technology, there's been a lot of different use cases across a wide range of different projects. I think obviously many of the sort of ZKL2 use cases, ZK rollup use cases are very common, and we have a number of people building on that, including Solve Labs. There's also a number of DeFi use cases. One of the interesting ones I think that's emerging also is this idea of centralized but verifiable computing, which is something that Hashflow is working on and with us. And the idea with that is you can actually build a centralized exchange that has all of the sort of performance and usability characteristics you would expect of a centralized exchange, but you can use ZK to verify the correct execution of the exchange itself, so that the exchange can't go rogue a la FTX. Or in general, that you can verify that the exchange is functioning properly, which doesn't remove the central party, but it massively reduces the necessary trust of that central party. So I think ZK, has a wide range of different use cases, and because the ZKVM is very versatile, we actually see a lot of these, different use cases being made practical pretty rapidly.
Wow, so many threads that we can follow up on, but we're going to stay focused, and I think it's time to talk about Boundless. I guess the first question is, what can you guys tell us about first Boundless in general, and more concretely, some timeline, milestones, vision, and such?
So absolutely, Boundless, I think, is really our sort of answer for trying to solve sort of the end-to-end problem of bringing ZK to every chain, right? We're calling it, a universal ZK protocol, and the idea is we want it to be possible for people on all of the existing chains, L1s, L2s, etc., to be able to run ZK programs off-chain and have them verified on-chain. And sort of Boundless actually consists of sort of a stack of technologies. Obviously the ZKVM is one of the core parts. We also have a sort of decentralized proof marketplace where basically requests for proofs and are able to meet with provers who produce the proofs. And then methods to do aggregation of the resulting proofs, get them verified on chain. But the end goal is really to provide ZK so that it's basically becomes easy to use everywhere. And part of that, so in order into building that, we actually already have a working test net internally, which is a private test net, and we have a number of partners on both the proving and the sort of proof demand side. We've actually been running that for a bit now, and we are shortly moving toward a public test net, and then obviously after that mainnet. But I think at this point we have a quite a solid design that we're quite happy with internally, and have had a number of third parties be giving us feedback on the details of that.
I'll add a couple things as well real quickly here, which is I think the need for Boundless became very clear to us at some point in time. A couple of the insights that led to the conclusion for a need for this universal ZK protocol for any chain is, for example, why do you work on a blockchain in the first place? You want trustlessness, you want censorship resistance. You don't, develop your product or your company, as a dApp or as a blockchain, unless those characteristics matter. And while reliance on a centralized prover is sufficient in lots of cases, and we think there's lots of room for innovation that enables, it does introduce a few different complexities. One of them, for example, is how do you facilitate a payment to that prover in a way that doesn't rely on native Web 2 payment rails? So if a DeFi project wants to use the ZKVM, but they're paying, their protocol depends on them having a credit card on file with Bonsai, that's clearly incompatible with the ethos in which you generally want to build on a blockchain in the first place. Another one is that provers are hard to run. So the hardware itself can be difficult to compile the prover, get it to run on CUDA. Also, in order to get appropriate performance in ZKVMs today, you really want to parallelize the proofs when these are really big proofs. And that's actually a really difficult process. And so, we saw a clear need to develop an end-to-end protocol that preserved the characteristics of building on chain in a way that allowed, really, I think the simplest way to describe it is in a way that allows it to be as simple and reliable to buy and pay for off-chain execution as it currently is to pay for on-chain execution today.
And one thing to note is actually even our existing internal testnet is fully decentralized right from the get-go, and will be fully censorship resistant. So I think that this idea that we're just going to allow execution to move off chain is going to be is sort of our fundamental goal. With the power of verifiable computing, we should be able to massively scale the amount of execution that's done, and without compromising on any of the properties that people expect from blockchain systems.
That's amazing. Jeremy, could you share more about the decentralization parts? For example, like the design of the prover network's mechanism, is it mainly driven by performance competition?
Yeah, so the mechanism is actually based on bidding, and there's a sort of a reverse auction component. One thing that's interesting to note is that we were able to build the design without introducing a new consensus mechanism at any point. So we don't actually have a new consensus domain. We're not running the proof marketplace as an L2 or an L1. It's actually a set of sort of smart contracts that operate on each of the chains where you want proofs to be able to be purchased, that does the settlement, along with sort of a peer-to-peer network that lets the provers communicate and interact with these on-chain contracts. And so I think it's a very interesting mechanism design. We'll probably reveal more details of that as we move closer to testnet. But the short of it is that we anticipate it allowing a level of sort of scaling that is very high, as well as maintaining a very high level of decentralization, so that the set of provers will be a completely open marketplace, and the ability to get proofs produced on any chain will be part of it right from the get-go, and it won't require any bridging or moving of payment information through a whole bunch of different steps. We're not going to require people to buy proofs in some new native currency that they need to exchange into. So we're really focusing on the usability of allowing people on whatever chain they're on to buy proofs in whatever the native currency for that chain is, which we think will be a huge unlock for people's ability to make use of this technology.
There's a really interesting characteristic that results from like the system that's Jeremy was describing it. You could probably raise $1 billion to build some new ZK native layer one, but there's enough blockchains today, right? Like that's the reality of the world. There's actually enough blockchains today, and that's our personal view. And so we really wanted to build a protocol that enhanced existing blockchains and gave them this, the power of succinct, verifiable compute off chain. And so like one, I think, simple way to understand this is today, if you look at a blockchain, they're only as powerful as their weakest node. Because of, the limits to the speed of light and how fast computers are, if every node in the network has to execute this smart contract, you need to keep the limit on execution quite low to, in order for these systems to work. And what Boundless will do is effectively enable any blockchain to be the power of the sum of its external or off-chain nodes. So you can imagine that every Boundless node, every prover that's connected to an existing blockchain actually increments the amount of execution capacity of that chain. And so that's a really fundamental concept that I think is easy to overlook, but it's so powerful. So, we'll really go from like a chain can go as fast in terms of execution, or like, let's think of Base and their intention to get to gigagas is like, we'll really go from a blockchain bounded by the speed of light to one that incrementally or horizontally scales with the number of nodes that connect to it.
Yeah, I think one way to look at this is we get rid of scarcity on execution, right? Right now, if you increase the demand on a blockchain, there's only a finite amount of room for execution in a block, and so the costs go up. If you do this proving off chain, then as the demand increases, more nodes can spin up, until AWS runs out of machines, and the costs don't continue to go up, because as long as it's profitable to do proving, more people are going to spin up more nodes. And so you move from a place of scarcity of execution to a space of, boundless execution, if you will. And that, I think, really is going to change the way blockchain works at a fundamental level. And our goal is not to, to Brett's point, not to make a new chain, but to bring this capability to every chain.
That's awesome. So we're basically making all the chains boundless and without creating more overhead in the industry.
That's our goal. That is
Yeah,
our goal.
yeah, that's really cool. And I think what's really nice is that Boundless offers a full stack solution. But while some players focus on individual components within the proof supply chain, optimizing proving or verification, so how do you see the balance between competition and the collaboration with these players?
Well, one of our goals is to make it so that people who are building point solutions where possible can integrate into the system. So, for example, Boundless, one of the things that we need to do is do aggregation, but we would, like to, we're working, for example, with Electron, and, other aggregators to be able to allow the aggregation technology to become a part of this sort of end-to-end solution. And in general, we want to be able to bring in, you know, people who are building new proving hardware to be part of the solution, people building tooling on different chains to be part of the solution. VLayer, for example, is working on improved tooling for accessing historical state in Ethereum. So I think that, if you, one way to think of it is that, similar to AWS, you create a basic capacity, and then that allows you to modularly choose which pieces of the puzzle to take, and whether to use like a first-party solution or a third-party solution. So we're very interested in creating an ecosystem to help both solve the end-to-end problem, but in a way that is, where we may have we may be slightly opinionated, but it's still very flexible, so that if people want to use some other technology for portions of it, that's still, as much as possible, something that they can do.
Yeah, just to echo what Jeremy was saying, this idea of this flexibility with sufficient opinions is a concept, or like a principle we refer to as internally as vertically integrated but modularly aligned. We really think it's important for folks to be able to use the stack and the parts that they need, not have vendor lock-in, etc. But at the same time, if you end up with a fully open protocol that's completely unopinionated, it's not clear where to start. And so we're also building a vertical solution across all of these different standards, such that really the mainstream can come in the blockchain community and have sort of an opinionated set of tools that they can use right off the bat. So, Boundless is already emerging as really an ecosystem. We're building a few of these things as well, like the ability to aggregate proofs. But also Electron, for example, is performing proof aggregation across many proof systems, including Halo 2 and Plonk and our ZKVM, and is participating as an aggregator within Boundless. Another good example is like, Aragon. They're building DAO governance tooling that utilizes the ZKVM. The proofs for those governance solutions will come from Boundless. We're talking to many bridges, and there's probably, somewhere around 10 examples now of teams that are starting to build within this ecosystem.
So, talking about developers, what should we expect from the user experience, the UX of Boundless? How is it going to be different than what we have today?
So there's actually a couple of different workflows to consider here, and we're actually, one of our goals is to be able to target a bunch of different use cases. Everything from, I'm making a new roll up, to I want to sort of do this idea of co-processing. I just want to call a contract on chain and get the results. And there's slightly different entry points, but to just walk through an example, in the co-processor use case, the person if you want a proof generated that runs some function call on Ethereum, you can either request it from within another smart contract, or you can be requested off chain. The entire process of the prover getting found, the proof getting generated, the proof getting aggregated, that landing on chain is all sort of built into the system from the user's perspective. They have some control over some of the details of that, what they're willing to pay, how much staking they want provers to, have in order to be allowed to participate. But at the end of the day, the proof lands on the chain in question, let's say ETH-L1, for example, and the settlement is made for the payment of that proof to the prover, and there's a callback invoked or whatever. So it can be, from the user's perspective, it's as easy as saying, I would like a proof, and then later a proof is delivered. And so the goal here is to really make that integration loop from the perspective of the developer making use of this system as tight and as simple as is possible, so that to the largest extent they don't have to learn a lot of new things in order to be able to use these systems, right?
Yeah, I'll just add that if we're successful, like what Jeremy's describing, is their developer experience shouldn't be that different, right? They should be able to use the tools that they love, not have to learn new, abstract technologies, and really just enjoy the benefits of ZK. And so the one major difference should be dramatic reductions in cost, privacy as sort of a programmable primitive, right? This idea of programmable privacy, which doesn't exist today on chains. And so really, we want to preserve their ability to work with the tools they love, but just be able to access the power that ZK offers.
I want to take a step back on this topic. So I've spent the past 2 weeks at the ZK Hacker House, and I've noticed that developers face challenges in fully understanding the various stacks. So the lack of benchmarking, being tricky and difficult to standardize, adds to the confusion when choosing the best stack for their products. So what advice would you offer to these developers? Are there any specific functionalities they should pay special attention to when making their decision?
I mean, I think the thing that we've found over and over again is that there's a lot of different sort of factors that go into these things. And while generally we have superior performance across the board, at the end of the day, because benchmarking is fundamentally a tricky thing and it depends on what your application is, we just recommend developers actually kick the tires on a number of different proof systems. And we've had lots of people do internal bake-offs and come back with the decision to go with us. But I think at the end of the day, it is the response, the developers really, if they want to get the right answer, should do the legwork of actually trying different systems. And the truth is that because, for example, we have led the way with the adoption of Risc-V and Rust-based sort of systems. Many of the sort of other companies building similar systems, their stuff, because it was based on ours, is quite compatible. And so really a lot of times the difficulty of trying both systems or whatever other systems are out there is not as high as people might think. And so I think we just recommend everyone do their own measurements. Because at the end of the day, what matters is which system runs the things you care about the fastest, and you know really what your requirements are as a developer.
I'll make a quick addition, which one of the things that's, for example, really difficult to quantify in open standards for benchmarks is even if you can get to some standard on an individual machine, how do you account for the efficiencies that are gained in terms of when you parallelize the generation of the proof, right? So the complexity just now scales across machines, and some systems are more compatible with parallelization than others. So Jeremy said, the developer experience is pretty consistent. We share some tooling with some of the other Risc-V ZKVMs. So you just write your protocol, and you have a Rust program that's quite easy to port over into our ZKVM. We support teams doing this regularly. If you want to know how fast, you want to see if we can make it go burr, just hit us up. We'll be happy to help you port that program over, send you some benchmarks, so you can really observe with your specific payload, how fast things can go in our ZKVM.
I wanted to follow up on Queenie's question and try and figure out how religious you are about your stack, and also how much room do you guys give on your roadmap to improving the underlying tech stack, right? So you started with Risc-V. As you mentioned, Jeremy, you are based on Stark, and I guess you can go even lower resolution, some kind of specific field I mean, how much thought are you guys giving to this actual stuff? Like, are you guys looking into other technologies as the space evolving, the ZK landscape evolving? Are you guys considering other technologies? Like, how does it work?
Yeah, so absolutely. We um, are not religious at all about the particular ZK mechanisms involved. I have very much a pragmatic engineering background, despite my love of math. So we really are always looking at the latest ZK research and evaluating what impact it would have on performance, on capabilities, and really using that to decide where we should adopt new mechanisms. Like we would happily change what field we're using, move to a non-Stark based proof system, whatever looks like it makes technical sense. Generally, what we have found so far is that while there's been a lot of really interesting advancements, um, the sort of end-to-end impact of a lot of those advancements so far have come out to be fairly, you know, 30% increase here, 40% increase there. And at this point, we're getting those levels of increases just by tuning code or doing things that are a lot easier. But absolutely, we will continue to improve and modify our proof system and always follow whatever the sort of best emerging um, directions are from the sort of ZK research space. Like, for example, we're looking at WIR right now, or a number of other modifications to Fry. We're looking at, some of the new work that's coming out on different methods for doing aggregations. So yeah, we do always follow that stuff, and happy to move to whatever is the fastest.
I'll add too, and I'll brag on Jeremy a little bit. I'm sure he wouldn't feel comfortable doing this himself. But if you look at a lot of the modern proof systems today, I'll use Circle Starks as an example. They're actually taking and using innovations that Jeremy designed into our version of the proof system. So, for example, like Circle Starks rely on Mercine 31 prime and its field, and Baby Bear was the first 31-bit field similar to Mercine that was used in a Stark-based proof system. And so I think people have actually underestimated the performance of our proof system in particular. It's really fast. It's really impressive to see how much performance we continue to get out of it. And when we look at some of the other options, that are out there, not only are they unproven, our proof system has 2 years of history now. So not only are they unproven, is the security models not clear, it's also not clear if they'll actually sort of be faster in many of these cases. Just as a concrete example as well, you can look at, there was a conversation in early October about where I think Vitalik said something like, in order to get the cost of proving Ethereum mainnet under $200,000, that proofs over binary fields will be required, something like Binius, for example. And what's funny is we actually see a path to get under 200K with our existing proof system. And so there's still tons of performance opportunities, I think through the next 6 months or roughly a year. And we think we can get to really impressive performance numbers and unit economics with what is really a tremendous proof system that has introduced a lot of innovation. Yeah, one other thing I'll mention is, as we were describing Boundless earlier, right? We described it as this like a modular set of protocols, and we're building one vertical integration. The ZKVM will be the first supported ZKVM, but we do intend to support other ZKVMs in the future, potentially other proof systems. That's all TBD. Clearly, we're not like sort of scoping that for our initial launch on mainnet. But we're very, very open to the reality of the fact that new proof systems will come about, new ZKVMs, et cetera, and we're building towards that future.
And actually, just as a concrete example, if Plonky 3 ran faster than our proof system today for the same circuit, we would just switch to it and drop the existing stuff. So we're very much interested in getting the end user the best experience.
So, you've mentioned on Twitter that the end game might be closer than many expect. I'm curious, how do you define this end game, and what key developments are driving us toward it?
Yeah, I mean, I think one thing to note is we have already passed the point where it is cheaper to generate a proof off chain and verified on chain than it is to execute on chain, even for very low gas cost chains. And I think that what we will see is most to all execution on every chain move into sort of ZK execution. And we will see everything move towards ZK validity, right? Like if we can get Ethereum to be inexpensive enough to prove every block, why would you not prove every block, right? And why would most things not move in that direction? I mean, I think there will always be some room for there are things like ZK optimistic and things like that that still probably do make sense. But I just think that this idea that most execution will be done by re-execution on every validator is just not going to be the long-term future. And I think we'll see real transition toward that even over the next year.
What's really interesting too is you can see this today, right? You see execution moving off chain via L2s. You see Celestia's roadmap and Ethereum's roadmap as, on-chain sequencing and DA, off-chain execution. There is no protocol to coordinate that off-chain execution today, and that's what Boundless is.
Amazing.
We always ask our guests if you can name one project that you are bullish about.
I'm gonna have to go with Hashflow on this one. I really like their direction. I think that this idea of centralized but verifiable is an interesting new design choice I think that the centralized but verifiable is an interesting new approach that sort of sits between the traditional approach and the sort of blockchain approach, and I'm very curious about how that's going to go. But I think it's a really interesting idea.
Yeah, there's so much cool stuff being built. It's hard to pick one. It's like picking a favorite child, I guess. But for me, I'm really bullish on privacy protocols. I think privacy is a fundamental right. The technology itself has been so inaccessible that it's been difficult to build them. So I'm a contrarian. So when somebody's really bearish about something, I think at some point in the future, privacy will get cracked. Really excited about what Anoma is doing in that field. They're using the ZKVM in a number of capacities as well. But even teams that we love, like the Aztec team, for example, just love the work that they're doing. I also think too, this is a little bit of a category, maybe not like a specific project, but I think people are underestimating, again, sort of from a performance perspective, how feasible client-side proving is going to be in general purpose ZKVMs. And so I think as a category of exciting interests and possibilities is maybe next year, teams building with general purpose ZKVMs, some minimal client-side proving within the browser or, on a device.
I'd also say I think ZK identity use cases or ways of integrating the existing Web 2 infrastructure in with ZK. For example, the idea of being able to verify Web 2 credentials using ZK on blockchain use cases, the sort of merger of some of the Web 2 and Web 3 worlds, I think is also very interesting to me.
Great answers. Rich in flavor, just as we like it. Jeremy, Brett, thank you so much for joining us today, sharing information about your journey so far and what you're up to next. For those interested to learn more, we've added some links in the show notes. Finally, I want to thank Queenie for co-hosting with me. Adios.